Hello, Year 9. So last lesson we looked at data displays. This lesson we're going to look at ways of describing those displays. Okay, we're going to look at the different shapes that data displays can have and what that tells us about the data. Okay, before we do that though, there's a few new words that we need to learn. We did speak about how there are lots of words in this topic. So once we get through this, we'll be able to use the proper language to describe the displays appropriately, okay, and descriptively, way that is not ambiguous. So a few terms here, some which you may know, some which you may have forgotten. Let's go through them. So when we talk about a set of data, the mode is the term that we use to talk about the most frequent score, okay, or the most frequent piece of data, okay, the most frequent data point is what we call the mode. Okay, now I made a mistake here. Symmetrical. Okay, if we have a data set that is symmetrical, it means the shape of it is going to look even. There's going to be sort of this axis of symmetry in the middle. If we had a histogram, it's going to roughly look something like this. Okay? Okay, a positively skewed set of data is when the mode is not in the middle. Okay? So if we have a histogram, the rough shape of it is going to look like this, where the mode, the peak of that histogram, is shifted to the left. And when it's to the left, we call that positively skewed. Okay, another way of thinking of that is there are more small numbers than there are big numbers. Okay, and that's an example of positively skewed data. Now, an example of positively skewed data might be the house prices in a particular suburb. Typically, you're going to have a range of house prices that are much common, and the costs of different houses in that suburb are going to be more centered around that kind of common range. However, every suburb is going to have certain properties that cost a lot more than the average or the most common. And that's sort of, there's going to be less of those more expensive houses though. So you're going to have a bunch of houses in a sort of affordable range, and it's going to tail off with a few more expensive ones there. So that's an example of positively skewed data looking at the house prices in a suburb. Okay, now negatively skewed data is the opposite. So if we have a histogram, the rough shape is going to look like that. Now the mode, the most common one, is going to be to the right. There's going to be a tail of the sort of amount, the small numbers, and a lot more big numbers in a negatively skewed data set. Okay, so those are different types of skewed. Now you can get some data sets where there is more than one value that is equally frequent with each other as the most frequent. We call that bimodal. So the rough shape of a bimodal data set is going to sort of have two peaks like that. So you've got two modes sort of spread out together, kind of looks like a camel's back, and we call that bimodal. Okay, so there are particular terms that we use to describe data sets and their spread, how that data is spread out. Okay, so let's look at a few examples here. We've got to describe the shape of each distribution as either symmetric, positively skewed, negatively skewed, or bimodal. And all we have to do is just look at that shape, say, is it slanted one way or the other? Or is it symmetrical, or does it have two peaks? So when we look at this first one here, if we just were to draw a rough outline of that set of data, so this is a dot plot, and you can see here the mode is very clearly shifted to the left. So remember, we call, if it's to the left, if we've got more small values, we call that positively skewed. So we can say that positively skewed for that first set. Now for B here, if we were to draw a rough outline of it, we've got two clear peaks there, two modes, so we call that bimodal for B. And then for this stem and leaf plot, we can also sort of draw an outline around those points. So I can go like that. Now, a stem and leaf plot is kind of like a dot plot, except rotated around. Okay, so if we were to look, we've got less small values and more big values, so that's going to be negatively skewed. So for this last one, negatively skewed. Okie dokie. Let's go to this last example here. Describe the shape of both data sets. So here, we're looking at a stem and leaf plot that is back to back. That is, we've got two separate data sets that are being described on the one stem and leaf plot. You've got females and all the data to do with females, and you've got males, but they're all linked to the stems in the middle. Okay, so for example, this first data point for females would be 19. So the stem is the first digit, the 9 is the last digit. And from here, you've got 10 and you've got 5 in the males. Okay, so that's how you would interpret that stem and leaf plot when you've got two data sets next to each other. We're going to describe the shape of both data sets in the back-to-back stem and leaf plot as either symmetric, positively skewed, negatively skewed, or bimodal. So when we look at the scores on the topic test, a lot more females were doing better than not so good. So you can see here there's a big peak towards the bigger numbers. So that's going to be negatively skewed. If you've got more bigger numbers than small numbers, negatively skewed. So females, negatively skewed. And then for the males here, we've got two modes, as you can be able to see by that shape. Okay, you can see there are 4 frequencies within that 2 stem. There are 4 values within that 4 stem. So you've got 2 modes here. So for the males, that data set is going to be bimodal. Okay, so those are some examples of describing the spread in data sets. If you have any questions, let me know in Microsoft Teams. I'll see you in the next video.